You don't know why it is, I mean, not working, but with some of the recordings that you just uploaded on YouTube, I have been able to do all the tasks. Thank you.
Awesome, awesome. Yeah, so it's part of our training. It is just part of it, yeah. So I know very well that the AWS Cloud Practitioner exam, if I'm to teach you the part exam, trust me, I can do it within just 1 week, and nobody will touch code. Nobody will touch AWS console, right? And you all pass neatly with a neat pass, good pass, right? But this course is not for just AWS exams, right? And I just decided to pull up one of the materials I typically used to teach beginners, right? AWS Cloud Practitioner without stressing them with the coding aspect and then the deployment and the labs, right? And they've been passing the exam perfectly. And this is one of them. So I have like a 10 to 12 week course, right? Maybe one of these, I'll just share the recordings with you guys, right? And it just talks about the theory of the cloud, right? For the beginners. But that wasn't the purpose or the intention of me creating this course to just give you theory, right? I just wanted you to have a taste of almost every part of what cloud or people in the cloud space do. So with the labs, as you are building the labs, you're having a taste of what cloud engineers, or let's say the DevOps guys really, really do, right? Then whenever I come to the slides and the theory, like what I'll do this morning, this is just like good for people who just want to know about the cloud. And like managers, top level executives, the executives, so that they will know what they are actually migrating to, right? Probably they want to move from on-premise to the cloud, just to give them an idea. So cloud practitioner is just to, according to AWS, it's just to acquaint you with the cloud and cloud concepts and what all the buzzwords mean, right? But as I said, my boot camp, what I built with the team, we are more focused on giving you a taste, right, of every aspect of the cloud. Okay, from engineering to architecture to everything. And in that way, see, if you sit for the exam, if you really want to even sit for the exam after all of this, there's no way you're going to fail. It is impossible, just like impossible, right? Awesome. So I'll just encourage all of you to keep on pushing, right? And just know that Shark is pushing us above the AWS Cloud Practitioner exam. The exam will never ask you to code anything or to build any lab. No. It's just theory multiple choice questions, like 65 multiple choice questions. A, B, C, D. Just keep on choosing A, B, C, D till you are done. It's as easy as it's like the easiest exam I know in the even the tech space. I can say tech space, AWS Cloud Practitioner exam, right? So don't think the level of difficulty with which I'm training you is the same as that of the exam. The exam will be way, 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 way below in difficulty. Trust me. My friend told me the stronger the training, the easier the battle, right? So I'm trying to give you guys something strong that when you get in the exam hall, even some of you who may maybe want to learn or prepare for the solutions architect, even after this course, preparing for the solutions architect itself should not be a stress. Trust me. I currently hold six, yet to enter into the seventh by the end of this month. And so if I'm 7 times certified and I'm saying this, you have to know that I'm telling you the gospel truth, right? Awesome. Any questions before we jump in? And in most of the labs, you realize that most of the issues you guys are facing, sometimes I jump into the call with you, and the issues are just about security groups or permissions. So please, when you are performing the labs, be careful about your security groups, the rules, and the permissions, right? And my team, myself, we provided most of the recordings, even the solutions to the lab. Lab one is done, lab two is done, lab three is done. I think we are yet to do the lab four and upload. So after this week, I may probably give you a 1 week cool off. I'm looking at that. It's either after this week or after the following. I'll give you like a 1 week cool off to just go over all the materials before we do the final capstone project. It's either I do that or I allow you to do the capstone project in 2 weeks instead of one, so that you feel more relaxed in doing it. If you even want 3 weeks, we can vote on that so that you take like a week or 2 or 3 to finish your final capstone project, right? And as promised, those who finish up to lab 4, you'll be given a certificate, right? Very soon we'll send out a form, you fill it, and then we'll send you a certificate if you've been able to do up to lab number 4. And those who do 5 and 6, you also get a different certificate, right? So we don't want to restrict your certificate to just the labs. And we may have an optional certificate pathway whereby you just do multiple choice questions, like just like the AWS Cloud Practitioner exam. So you answer multiple choice questions from maybe about 5 sets without doing a lab. We also give you a certificate, right? So we are creating like different pathways to the certificates will be given out. I hope that sounds good to you. If it sounds good, just type good in the chat for me. And we know we are all on the same page. Great. Now, for the sake of those who are joining us for the first time, right? Some people are joining us for the first time. Oh, I was muted all as well. Sorry. Then let me go over it again. Sorry, guys. Okay, team. So if you're joining us for the first time, the very first time, right? I've pasted this link in the chat right here in the call for you. Okay. So you come to this link, it will take you to this page. And on this page, we have so many things that helps you to learn, right? To understand the AWS cloud and also to prepare for the AWS exam. So what are some of the things we have here on this page? We have the curriculum. I think most of you have seen it already. Then the recordings. So you may want to focus more on this side. All the sessions we've had so far, the recordings of the sessions. So you click on recordings. Then we've done only 2 weeks so far. So this week 1 and week 2, right? You open it up, it gives you the recordings for that week. Okay. Then week 2 we've done that. You just watch the 2 recordings, even before you start attending the lab, right? Even one of the labs has been done. I'll also upload it here. So week 2, we actually had 2 variations of the lab. Those who have the paid version of AWS account, which I doubt most of you have, they will go with the RDS. That is the option A, right? And the option B, I also uploaded it right here. That is when I did the same lab again, but this time we did it with 2 EC2s, right? So I also uploaded here so that when you are doing lab number 3, you wouldn't have an issue because there are actually 2 pathways in lab number 3. Let me show you. So lab number 3, this is with a 2-tier application. So when you begin this lab, The first part, you do the lab with RDS, but I'm sure that many of you are having problems deploying RDS, right? So with that, created another pathway. It is the B. So when you're doing lab number three, please start from here, part B, right? And you just follow the instructions to access this lab. Okay, good. So that's just with the intro if you are joining us for the first time. Then we have some flashcards, we have some jokes, we have some, yeah, story. It's a very difficult concept, right? So one of the very difficult concepts, I choose to begin explaining them with a story. And we saw that last week. Okay. And most of you gave very good positive feedback about that, and it was quite encouraging. So very soon, as I said, we are going to give you guys I think we've already given you, right? So we have okay. Then yeah, uh, that's why we usually upload things very quickly. If you want to get a recordings quickly, you sometimes see it on YouTube before it even gets to our page. And I've also copied this link and I put it in the chat for us here in this call. We also usually do that in the announcement sections, right? So if you've missed any recordings, all the recordings are here actually, together with these short videos. So you see the recordings, the live recordings or sessions are different from these short videos. And these short videos are just my notes, right? My notes, the notes I used to teach people to pass the AWS exams. And I've converted the notes using AI to videos. So instead of reading notes, you can watch these videos and you still get the same notes I give to people to pass the exam. The PDF versions are ready. So we are going to also upload the PDF version of the notes, right? And where will you find these stuff when you come here? So you come to the self-paced section. You hit on the self-paced section. Same videos on YouTube, you find them in the self-paced section, right? So when you come to the self-paced section, you see from 1 all the way to 10, just as we have it on our YouTube, those videos are here. And so the video is there, and we are yet to upload the notes itself. So if you don't want to watch the video and you want to actually read the notes yourself, today we will upload all the notes on this platform. And the notes are so powerful. Even with just the notes alone, you are good to pass the AWS Cloud Practitioner exam, right? Without doing any of the labs, without watching any of my sessions, right? So it just consolidated everything you need to just ace AWS exams, and also not just that, but will become a real cloud practitioner. After writing that AWS exam, they give you the title cloud practitioner. But see, when I wrote the exam for the first time, I never felt like a cloud practitioner after passing that exam. Even after passing the exam, I felt like, see, I still can't do nothing with the cloud. That is why in this boot camp, I'm not just building it with theory, but practical, so that when you are done and you call yourself a cloud practitioner, you really know that you are a real cloud practitioner. So that has been just one of the things that people have raised or concern they have against the AWS certification exam. They are like, when you finish the exam, why do you call yourself a solutions architect? Because you just wrote a multiple choice exam. So why are you calling yourself an AWS engineer, right? And it is true. When I also passed the solutions architect certificate, I didn't feel like a solutions architect. It sounds funny, right? But I felt like I just read some notes and passed the exam. I'm very good at passing theory exams, so I didn't really feel like a solution architect. So I got a job working with the cloud for close to, should I say, 4 or 5 years now. Then I started building on the cloud itself. Then I can now feel confident calling myself a cloud engineer or solution architect. So if you're running through this course, you can pass the exam without touching any of the labs. But see, I'm telling the truth, you will not feel like an engineer, even if after passing the exam. So please take one lab, they are all free, and then exercise your brain with them. Awesome. So let's get started with today's session. So today, what is the plan for today? To just review all that we've learned about the cloud. That's number one. Number two, we want to understand how the cloud expands to do what we call auto scaling. So auto scaling means that when you bring all your computers or your servers to the cloud, and then you want to now serve your clients or your customers from the cloud. So let's say I had a website. The website was sitting on my laptop in my office, and anyone who wanted to get information for about CloudWish had to type www.cloudwishat.com, right? And that message comes to my laptop. My laptop is a server. And my laptop now sends you feedback and you can now see my website, like let's say this website. This is the old school way of doing it. Now the cloud way, I buy a computer on the cloud with AWS. I now put my website on that cloud server. I hope most of you have done that lab, right? Then when people request www to your shop.com, they now get the response from the cloud server, not your server or your laptop, right? And that is the cloud. Now, when many people are requesting for your service, okay, it can overwhelm your server. So AWS gives us a way of making sure that your server can create multiples of itself. It's funny, right? And then serve so many people, many more people than one computer can handle. And that's why we call automatic scaling. It can multiply or scale to meet any incoming traffic. Okay, and that's what we will look at with a story. Okay, so cloud computing. All that we've been doing so well all this while is that we've learned that it is the on-demand delivery, right? On-demand means when you need it, you can provision it for yourself without any stress. So on-demand delivery of IT resources, okay, over the internet. So you sitting at your house or your home, you can provide for yourself. The actual word we use is provision, right? You can provide for yourself any computer you want. If you want a computer with a very powerful memory, large disk space, whatever you want, you can pay for it. And how will you get access to it? It is over the internet. So once you can connect your laptop to the internet, you can create an account with Amazon AWS, as most of you have already created. You can just sit at home and then place an order for a huge, ginormous monster computer, right? To do whatever workload you want to use it for. And how do you pay for it? It is a pay as you go. Pay as you go means you only pay for what you use, right? Like the electricity you use in your home. If you want to use just 5 CDs, you pay for 5 CDs. When it's done, it goes off. So that's how the cloud works. And this is what we've been doing all this while learning about how to provide these IT resources for ourselves over the internet. It's as simple as that. Now, these resources, we didn't just say IT computers or servers because it can extend beyond just servers. Right now, we have services like AI services. You can still sit at your home and pay for certain access to AI services. They have a whole service called Amazon Bedrock, and that's what I currently use at work, right? We use to create digital Okay, team, we had a network glitch over there. Yeah, sorry for that. Okay, so give us a second. Okay, second. Okay, let's continue. So we're just explaining the cloud concept, right? And what we mentioned was that so far we've seen that we can sit at the comfort of our home and then deploy or have access to whether AI services, whether computer servers, no matter how powerful they are, we can have access to any of these things using with just an internet connection. Okay, great. So we have the traditional IT versus cloud computing. Traditional, everything is on our premise, right? Cloud, we provide our access to all of these services using through the internet. And we saw how these things work, right? Traditional IT, you have these physical servers in your home. Cloud computing, they are virtual servers in sitting in data centers, right? Of the cloud provider, whether it's Google, Amazon, or let's say Azure or Alibaba Cloud, it can be any of them. Okay. Then we also saw that traditional IT, you have to pay huge amounts to have these computers brought to your home, right, or your office. But cloud, you only pay for what you use, right? So you pay in bits. That's what we call operational expenditure. Then scaling, right? If you want to scale, scaling means you are getting more clients or customers, and the server you bought, that box you bought, okay, the system unit is not is right now is under stress because your subscribers or your users have moved from, let's say, 100 to 1 million overnight. Your your product has gone viral. Now everyone wants to come to your website to come and check it out. And your web server serving your website cannot handle 1 million people on it, right? So if you want to buy more servers, you may have to now order for it. Maybe you didn't even buy it in Ghana or you didn't buy it from your country. You now have to order it overseas. And it's going to take some months or weeks before it gets to your homeland. And what happens within that period? Will you lose your clients or your subscribers? That's the big question, right? So with the cloud, you can auto scale within minutes. Within minutes, your servers or your computers, right, can multiply to meet whatever demand or traffic that is coming to your service. And that is what we are going to focus on today, the auto scaling aspect of the cloud. How is this possible? How is it possible for servers to just replicate themselves, right, to serve the number of clients that are coming in? We're going to understand that today. Awesome. Then there's one thing that we also looked at, cloud service models, right? So you have the pizza analogy. When you're making pizza at home, so you have to do everything. Even the oven, you have to make sure you provide yourself with the oven, the flour, the toppings, every single thing, you're taking care of it. Then we also have a take and bake. You go to the shop, you buy everything's already made, you just put it in the oven and then you bake it, right? Then the delivery over here, you're not even buying the raw or let's say the already made pizza which just needs to be baked. You just order for it and they bring it to your home. Everything is ready. So even with the first three, we understand you are choosing the instance you want, you are choosing the operating system, almost everything, right? So you have full control. Then the PAS, okay, that one you don't choose the operating system, you don't choose the type of instance. AWS just provides you the type of instance, right? And then you just bring your code. So that's the PAS. Then the last one, the SaaS. Okay, this one, everything's already done for you. Just jump on the software and you start using it. An example is the Google Doc and Google Sheets. You don't have to install any software. You just open Google Sheets and you start using it for your Excel or your spreadsheet work. So these are also some service models that we looked at. The traditional one is the on-prem one. You buy the server yourself, bring it home. You have full control of your servers. You have to do the cleaning, everything yourself. Then they take and bake. Still, you're not buying the physical server and bringing it to your company, but you still have a lot of control. The PAS, you don't even think about the server at all. Just focus on your code or your application, right? And when you are done, give it to AWS. AWS will handle the kind of server that will pick up your code, right? And the last one, the SaaS, you don't even think of the code, you don't think of the server, you just start using the software that the SaaS. Okay, so we are just going to focus on what we want to focus on today. Auto scaling. Auto scaling. How is it possible that instead of waiting for weeks to get a server up and running, now we have the servers can now we can get more servers within minutes. So let's jump onto that. Good. If so far all we've said is clear, just give me a clear in the chat. Just type clear in the chat. And this our story explainer for the week. Awesome. So that was a quick review at what we've been doing all this while. Okay. So let's give ourselves a minute, take some fresh air, stand up, walk around, and we'll get started with the second part, where we now delve into the world of how AWS does auto scaling. So 1 minute, go grab a cup of water and let's continue this. Okay, we are back. Let's continue. So we have the Trotro station at Circle. How many of you have been to Circle before? Those of you in Ghana, how many of you have been to Circle? How does the place look like? Is it a calm area? Tell me in the chat. Is it a calm or is it a very noisy area? Our friends from other countries want to know. Someone says very noisy. Oh, I thought it was a residential area. Okay, congested, crowded. Wow. Okay. And we are looking at the Trotro station. So for our friends who don't know what the Trotro is, let me show you what the Trotro is. This, let me see. So this is what we call Trotro. See, these ones don't exist. But I think these were the very first versions of Trotro, right? It's just like a public transport vehicle, a vehicle for, we don't usually have lots of buses here. This is like our bus here in Ghana. And I think even in Nigeria, they have this also. I don't know what about Namibia and the rest, but maybe our friends from Namibia can tell us. Do you have these kind of vehicles there? I nearly visited Namibia the other time, but I couldn't get the opportunity to go there. I went to South Africa, but I didn't see any of these things there. Or maybe where I went to, that's why I didn't see them. So so the conductor is a guy hanging here, right? So this is a guy who takes money from you when you enter the trotro. Also, when the trotro is parked, you see this guy. They're the ones who look for clients for the van or the bus, right? So these kind of vehicles, we call them trotro, and you see them many places, right? And this is how typically a trotro station looks like this. It can be this congested. So you see all of these vans, they're just waiting to carry people to their various destinations. And at times you come to these trotro stations, right? And then there's a queue because the supply of these trotros is very low, right? As compared to the demand, the number of in the queue, right? So that's where the conductor needs to step in and make sure that probably he can make some calls to his friends who are elsewhere to come over to help reduce the length of the queue, right? So we can call in for, we call it reinforcement or help. Okay, okay. Awesome. So we've seen the total station. I'll give you context. Now let's go back. So when you come to Ghana, usually they are the cheapest means of transport in Ghana, right? The cheapest. So anywhere you want to go, you can use a trotro. So when you come to Ghana, please ask for the nearest trotro station. Okay, now Circle is like a central point in Accra, right? And it has a very big trotro station. You can go and pick one from there to almost any destination in Accra. You get a trotro to the destination. Awesome. Great. Okay. So every Ghanaian knows the trotro station, vehicles fill up and leave, right? I've given the context. Now, let's look at what is happening in the trotro. So we have one station, many trotros, right? So for instance, you have three trotros that are parked here. All of them are going to Medina. And we assume that they are all identical. Obviously, not the case in real life. Almost every car can become a trotro if it looks like a bus or a minivan. So they do the exact same thing, picking the same clients almost all the time, right? From this station to the destination. So this like within the big circle station, there's a portion of it called Medina Station. So if you're going to Medina, you have to find that sub-station within the whole total station, right? And then you look for where will I get a Medina vehicle? Then they'll direct you there. Okay, good. So any of these routes going to Medina can definitely carry people who want to go to Medina there. So the main idea is that we are going to liken these trotros, okay, to what we call or to our servers or EC2s. And we are trying to make sure that they are identical because if you want EC2s to do auto scaling, they have to be of the same kind, of the same type. That is why we are forcing our trotros to be of the same color and everything because we want to be able to liken them or compare them to our EC2s very soon. Okay, so AWS thinks about our servers in this way, right? The servers which are serving the traffic. The traffic is the people coming to the station and want to go to their destination. So AWS looks at the traffic coming to your infrastructure, okay, as people coming to these various tutorials, right? So if the traffic is a lot, you have a long queue, right? Or a lot of bytes or requests are moving to your web server, then there'll be pressure on it if it's just one server or one EC2. But if there are many of them, then these can help save the long queue, right? Or if you talk about web traffic, the traffic that is coming in, if there are many of these cars, then there will never be a queue at the station. Always people get full, the bus moves away, the next one takes the next set of people, and then you come there, literally there's no queue. So if our EC2s are configured very well, okay, with what we call the auto scaling, then constantly those who are requesting information from our website, we are sure that our EC2s are always available to handle any number of requests that is coming in. Awesome. Now we have a conductor, right? So look at this conductor guy. So this conductor is standing at one place. We have these trotters parked here. Now what happens is that, okay, when people come, he directs the people to these trotters that here you go to this T1, trotro 1, trotro 2, trotro 3. So that at the end of the day, he makes sure that the trotters that are parked there are all carrying people, right? So he's not waiting to fill the request to just one of these trotters. Then it means there'll be a lot of pressure on this trotter, right? So he makes sure he distributes the people evenly or in a round robin. Round robin means you take one, 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 you take one. So there can be a different algorithms working between, right? And this guy who we are the conductor, we will call him in AWS context the load balancer. So just get that one. So load balancer will now sit in front of our throttles. And as we said earlier, that these throttles are just like our servers, right? So we will place a load balancer in front of these servers. Okay. So as the traffic is coming in, the load balancer will say, you go to this server, you go to this server, you go to this server, so that no single server takes too much pressure or requests and get overwhelmed or burn out. So we've seen the servers, we've seen the load balancer. At this point, if it is clear, type clear for me before I proceed. We're taking it slowly. Is it clear? Okay, great. So the load balancer or the conductor, he has visibility and he knows he can actually see whether this throttle is getting filled faster than this one, right? So he's just monitoring whatever is going on. And according to what he sees, that's how he distributes the traffic. And that's how the load balancer also works on AWS. Good. A lot of you are saying clear. Awesome, awesome, awesome. You guys are good. You're great. Fantastic. So right now, you know what the load balancer does. Okay, let's continue. Now, so we've seen what the ELB, that's the elastic load balancer does. Now, let's look at something happening here. Now, when demand spikes, okay, when demand spikes, so around 11 a.m., let's say that number of passengers waiting at just 15, and we have so many cars, right? We may not need all of these cars to be here, right? If they are just 50 people, because one of these trotters can take, let's say, around 15 people. So if you have about 6 trotters and the queue is just having 50 people in it, then these guys here will just be here for nothing. They may just sit around and not have any clients, right? And it will literally be like we are wasting their time. In the same way, when you have a lot of servers, right? And then the servers are not being utilized, you're actually wasting electricity because those servers are consuming power, right? So it would have been better if we had a way of knowing the number of people in the queue. Then based on that, we bring a certain number of totrols around, right, to serve those people. And if you know that within a certain period of the day, we don't have so much traffic or we don't have a long queue, we don't need to bring lots of totrols around. You can just let one totrol be at the station to serve the people who are coming, right? Because the traffic is low. So that's the same exact idea. Work, everybody needs to get somewhere, 7 a.m., between the hours of 7 to 9 a.m., where everybody is moving, right? And lots of these short routes to be available, right? We need lots of these short routes to be available at what we call the rush hour, okay? So rush hour, we need more short routes, so we add more short routes. To the red ones are the extra ones we add during the rush hour to serve high traffic that is coming in, right? But when the traffic goes low around, let's say 11, then we have to just reduce the number of totrols. So let's just look at what is happening here. Just look at the time carefully for me. So the time is here. Let me minimize this a little. Okay, so this, let me just replay this. So at 7 in the morning, you have high traffic, more servers are created, right? 11 a.m., the place is getting quiet. Those extra servers, we take them off. This, my friends, is what we call auto scaling. Automatically, we detect the number of traffic or people, we scale up. Scaling up means we add more servers automatically to serve the traffic. Then when it becomes quiet, we have to scale down because there's low traffic. Now, who can tell me on Jumia or some of these kind of web stores, e-commerce stores, there are certain days that there's very high traffic. I want someone to get the name of that day for me in the chat. We have a name they usually call that name that day, right? It's called something day. Black Day, you guys are good. So on Black Fridays or doing promotions, right? There's going to be a huge spike in the number of people visiting the website. Everyone wants to buy something at a very cheap, affordable price. So if you are the cloud engineer for that company, Jumia, you should be prepared in advance, right? To scale up to meet that traffic. Else, when the traffic is too high, the whole website just becomes slow. It become like a DDoS attack, right? Whereby hackers are trying to just send so many requests to your website, and then your website becomes crazily slow. So in order to avoid that, AWS has created this auto scaling for us to deal with that issue. Okay. Now, how the station really knows when to scale, right? So there must be something we call the policy. Okay. So the station master doesn't randomly decide, as we've already seen, right? If you see that the average waiting time is more than, let's say, 5 minutes, continuously for 3 minutes, then he adds one to he can give himself some rules, a rule like that. Or when you look at the length of the queue, if the people in the queue are more than, let's say, 50, right? Then he has to add about one totro or two totros to come and help. He has to make a call. So there is a policy which guides the provisioning of more servers. And we may look at that, or we will see that in the lab when we're doing the lab, right? So AWS uses the same idea, but instead of wait time, AWS can look at the server's capacity. So it's looking at the servers through its monitoring services, right? We have CloudWatch, which monitors CPU utilization. It gets log of whether the CPU or the CPU inside the server is being used above, let's say, 70%. Means that there's a lot of pressure or stress on that CPU, right? So it then has to add another server. Then the load or the traffic will now be distributed for the two. So that instead of all the 80% going on one CPU, it now be 40-40, and now the pressure goes down. So we can set a what we call target tracking to just monitor the CPUs that are available. If they are exceeding a certain threshold, we can just say, hey, we don't want the CPU utilization to ever exceed 70%. And then we leave that work for AWS to do. So AWS is the one who takes the burden of making sure that the CPUs of our servers don't exceed 70%, right? So let's say we have servers. Once it realizes that each of these computers, okay, their CPUs are going above 70%, then it has to automatically scale, right? It has to automatically scale and add more servers so that these extra servers will come and help bring down the CPU utilization below 70%. And that way, you don't even have to think of when to do that. AWS will think of when to do that by constantly monitoring your target for you or your CPU utilization for you. And we just add up the servers for you, right? And this is how AWS does the magic. So you are having your website on AWS, you set up your auto scaling with a policy of target tracking, okay? And you set up a particular policy, let's say a target that CPU utilization should not go above 70%. The rest of the work is done by AWS. You can go to sleep. So on Black Fridays, you don't have to worry or be worried as a cloud engineer. Oh my God, I have to go in there and add more servers. No, you don't do that manually. Automatically, AWS will always make sure that the server's CPU utilization never goes beyond 70. So if they have to add 10 more servers to achieve that, they will do that. If they have to add 20 more servers to achieve that, they will do that. But this is where the game becomes crazy, right? Wouldn't that affect my cost? Someone will ask that question. Okay, fine. I'm trying to make sure that utilization goes below 70. But what about if AWS has to add 100 servers? Then I'll go and look at my AWS bill after the Black Friday. The bill will be higher than what people even purchased. That would be crazy, right? So we have a maximum and a minimum that you can define when you are creating this policy, right? So that it doesn't go haywire, like out of the range. Awesome. Now, another question. During all of this, these are cloud servers, anything can happen to them, right? And we want to make sure that we have high availability. So you made a phone call as the station master. You need more throttles to be able to serve the people to make sure that the queue doesn't go be above a certain length. What about if one of the throttles you brought got got broken down, right? What do you do? So definitely you are monitoring all the throttles, you have visibility, right? The same way AWS has visibility of all the servers that are serving the traffic. So if one of them goes bad or gets bad, all that happens is that it is replaced automatically. It's also part of the setup of the auto scaling. So we have what we call the auto scaling group. It's a group of servers. So when we need an extra throttle, we call you to join the group of throttles serving the Medina station. In the same way, when we need an extra EC2 for our web server, according to the traffic and the policy that we have, we create another identical EC2 and add him to the auto scaling group. Now, within the auto scaling group, as I said, there are health checks. Every single server in that group is being monitored to see whether they are healthy or not healthy. So as soon as one breaks down, automatically another identical one is created to replace it, right? And that is what we call automatic health checks to replace these servers when any of them goes bad or wrong, so that our traffic or what we are trying to serve is not affected badly, right? Awesome. And it is done by the auto scaling group for us automatically. So we now these servers, as I mentioned, we make sure that each of them is identical, right? We don't want to go and bring an odd server into their group. So there's a launch template we create. And in the launch template, we specify all the things we need a server to look like. It's like specifying, I want the throttle to have, let's say, 16 seats or 15 seats in the throttle. I want it to be yellow in color. So you specify the things you need the server to have in the launch template. And then you give this launch template to the auto scaling group. So each time it's going to create a new server, it just looks at the launch template. And based on what it has in the launch template, it will create a new server, right? It's that simple. That is how come the server cycle, because all in a launch template and hand it over to the auto-scaling group. So that when we need more, it looks at the launch template and creates a new one for us. Okay, so there's self-healing, right? When something goes back, it's taken off and replaced, and that's what we call self-healing, provided by health checks. Guys, you've done so well. We are almost at the end of all of this. Now we have two types of conductors, and one is fast, one is slow, right? We don't want to get too much into technical details, but just know there used to be three, but one of them called the classic load balancer, it has been taken off. So right now we only have two, the application load balancer and then the network load balancer. So with the application load balancer, he likes asking a lot of questions when you are coming. Where are you going to? Oh, going to Medina, then go over here to this vehicle. Where are you going to? You're going to, let's say, Tantra Hills. Okay, go to this car. He likes asking questions before he tells you where to go to, right? But the other guy, who is a network load balancer, he doesn't ask you questions. Once you get close to him, you just say, hey, go here, next, go here, next, go here, next, go here, next, go here. He doesn't ask you any question. So this one, this is what we call the application layer. And this one functions as what we call the network layer, right? So that's what I just want you to know about these two. So usually in our experiments or in our labs, we'll be using the application load balancer. But for those who deal with high-speed applications, okay, they will usually use the network load balancer, right? Usually for high-speed applications. Okay, awesome. If you are good so far, just type good for me in the chat. If you enjoyed this walkthrough, let's type good for the chat. So right now we are going to go back to AWS terms to just summarize all that we've learned so far. Awesome. So we said that the third role that we've looked so far was just standing in the place of what? A server or an EC2 for us. The conductor who decides who goes to sit in which throttle. In terms of AWS, who decides where the web traffic, which server the web traffic should go to is our load balancer, right? Distributes incoming passengers across all available throttles. In AWS terms, distributes the web traffic to the servers. It's a very fun concept, right? Then the last one, the station master, right? The one doing the monitoring to decide whether we need more cars or few cars, right? Who will make a call for more throttles to be deployed to the station, or who will say, hey, you guys, we don't need many like throttles again. We just need one throttle, so you can find another station and go to. Thank you for helping us. That's the station master. That's our auto scaling, right? Auto scaling group. Okay. Then the ELB health check. It looks at for it's monitoring to see whether there are any broken throttles. It gets them pulled out and then it replaces them. Awesome. Hope you like the story. Sweet, right? If you enjoy the story, just say sweet. Give me a sweet. Give me a sweet. Then we move on to our slides. Sweet, 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 sweet. Yeah. Great, great, great. Okay. We take a 2 minutes break and we continue with our slides. This is a little longer, right? So at least you can go and get some food and eat and come back. Okay. All right, we're back. Let's continue. So, guys, some of my friends told me that they have a better story than this. So please, if you have a better story, see, it's an open source project. Send me your story. Maybe you can explain this in a better way or with another story. I would love to hear your story, right? So just DM me your story, okay? And then we'll add it to our stories, right? The same jokes, right? Let me see. I think we were to create a section for you to add. Okay, we've not yet added it here. So we'll create a section here whereby you can submit your own story, and we may replace our stories with yours if you see yours is better, right? Awesome. But I think with the jokes, you can do that. Let me see. With the jokes section, I think, yeah, you can submit your own joke. So we'll do a similar thing for the stories also. If you have a better story, we'll just allow you to submit your own, right? Awesome. Now tell me, before we even go to the slides, which of these resources here do you think you are enjoying the most? The flashcards, the jokes, the self-paced videos, the recordings, the slides. Which of these resources so far have you really utilized or are you really enjoying? Okay, someone is saying self-paced videos. Someone is saying the recordings. Okay. Are you guys using the flashcards at all? Or maybe you want to finish the course before you now go to the flashcards for the exam prep, right? I'm sure. That's some of you, that's a strategy. That let me just focus on recordings and the self-paced videos. Then later on, I'll go to the flashcards when I'm ready to write the exam. It's also a good strategy, right? And very soon, as I said, today we'll add the notes. The notes. So you're going to go to the self-paced section. You not just have the self-paced videos, but when you click on video, you get video. When you click on notes, you also get the notes. If we have the audio will also be uploaded today. They are all ready. Okay. It's good to know what you guys have been utilizing for your learning. Awesome. Then some of you also requested. So we will have about just 1 or 2 sessions where we just take you through exam questions. Maybe 2 different sets to prepare you for your exam. We'll do that. We are just here to help you guys become more confident and then ace that exam. Awesome. So we move on to our slides for today. So I downloaded mine, about to open it up, and voila, here it is. Okay, let's continue. So far so good. Almost done with this whole bootcamp, week 3, scaling, automation, and DevOps. So we're looking at why scaling matters, right? Then we look at vertical versus horizontal scaling, application load balancer. We've already seen that guy, right? Auto scaling group, we've also heard of that guy already. CloudWatch. I spoke about monitoring CPU utilization, right? And that's a service that does that. We call it CloudWatch. These are our eyes in AWS. It monitors everything. It sees everyone. Okay, then we have the CI/CD pipelines. This one was in the lab, I think lab 6, right? This is a little advanced. And this lab is not compulsory, right? You can still ignore this lab. But see, if you are here to do the hard thing, just do it and be free. And we also make sure we solve it for you. So don't worry. Then ask, we'll just describe our projects and allow you guys to ask questions about the future of the projects you're going to be building, right? So let's do this quickly. We've already spoken about all of these things, so I'll just spend like 5 minutes on this. Then we focus a little on CI/CD and then the project's Q&A. Awesome, let's go. So why one server is never enough? And we've explained this, right? Your application goes viral, your website goes viral. You can't see my slides. Oh, that's bad. Hold on. Let me share my screen again. Can you see it now? Oh, sorry. How did that happen? Okay. So this is our plan for the day, as I already described. Why scaling matters, vertical, horizontal scaling, application load balancer, auto scaling groups, CloudWatch, CI/CD pipelines, and projects. Good. So let's go. So we are saying that this is the issue, right? If you're architecting a solution for a client, and this is one of the reasons why we even advise people to move to the cloud because of auto scaling. You don't have this when your computers are on your premise, right? You just buy one big server. Later, when you get more clients, then you have to go and buy another server. You cannot automatically scale. It may take you 3 weeks to even be able to scale. But with AWS, you can set up an auto scaling group, put a load balancer in front of them, in front of the servers. Then, whenever there's high traffic, the numbers multiply, your servers multiply. When it's low traffic, then the number reduces to just serve the low traffic. That's the amazing thing about the cloud, auto scaling. Good. Now, if you just have one server and it's being overwhelmed, it will crash, right? It will crash and you get failure. Your whole application will fail. So single point of failure means that the way you've designed your solution is such that when something happens to one of the things in your solution, the whole solution goes down. So if you have an architecture and you have only one web server sitting in your office and something happens to that web server, your whole app goes down. Nobody can have an app. So you want to avert this situation. Also, when there's so much traffic at one server, it will be overwhelmed. It will burn, right? It cannot handle it. Also, another thing, you decided that, okay, fine, I want to be able to handle any number of requests. So I know that one server is enough. But because any surprise can happen, or I can be surprised, right, on any day, let me buy 5 servers instead of one. See, that is way expensive, right? And even if you are using the 5 servers, every day is not a Black Friday. What I say? I said every day is not a Black Friday. So maybe those 5 servers can be good for Black Fridays. But what about all the other days out of the 30 days in a month, right? If just one day is a Black Friday, or let's say out of 4 days, which are Black Fridays, the rest which are not Black Fridays, 5 servers will just be sitting down idle, and only one of them will really be doing the work. The rest will just be consuming electricity and power and what have you. So it's just a stress on your money, right? Waste of money. So moving to the cloud, you don't have to have, or you don't have to be bothered with any of these issues. But let me just say one thing quickly. It is still possible to move to the cloud and still have one server working without auto scaling. So auto scaling is not something that happens automatically per se. It's something that you have to set up. You have to architect it. You have to engineer it, right? So the fact that I'm saying that cloud on the cloud, we have auto scaling, you have to take advantage of the auto scaling that is there. So when you create one server and you don't set it up with auto scaling into an auto scaling, let's say architecture, then it will still just be like at the on-premise setup, right? So if you're here, you are planning on building a company and you know your product is going to go viral or it's already going viral and you want to move it in the cloud, please ask your engineers to architect for this for you, okay? They should architect auto scaling for you, not just one server serving your app. Okay, awesome. Vertical versus horizontal scaling. Now, the vertical one is the one you have to buy the servers. Let's go over that again. So vertical versus horizontal. So in vertical, okay, when you have one big server and you realize that the traffic coming in, okay, is overwhelming the server, you need more CPU. So they say the CPU you have is about, let me say, not able to serve the clients you have. So you want to buy a much bigger CPU, right? The RAM you have is not able to serve. You have about, let's say, 12 gigabyte RAM. Now you realize that you need a higher RAM, like let's say 32 gigabyte RAM. So you may just remove that 12 gigabyte, go and buy 32. Next time you realize that you need more than 32, you need 64, you go and buy 64. You realize you need more than 64, 128, you go and buy 128. The next time you want to go and buy something that is higher than 122, maybe 256. You go to the shop and they tell you we don't have 256, and then it means you are stuck. If you want 256, wait for 2 months before you can get to the 256 from overseas. So just changing one component and increasing the capacity of one component inside your server, we can call that vertical scaling, right? You are scaling the thing vertically, meaning that you're just trying to improve upon the capacity of the components inside your server. And this feels like it is simple. Just remove the RAM and then insert in a new one, which is bigger and better, right? But it gets to a point in time whereby going above that is not possible. Let's say you get 256 and you now want to get 512, and they tell you we don't have 512. What do you do? It means you've now hit the ceiling, right? So that is one of the disadvantages, because it gets to a point in time that you may not be able to go beyond that. So there will be what we call the hard limit, right? But initially, it may feel like simple, just replace the RAM, keep on replacing with the higher one. But get to a point in time that you cannot get one that is higher than what you have. And also, when you are changing the RAM, you have to reboot the server, right? And that may cause a downtime. Then your customers will not be able to access your website during that time that you are changing the RAM, right? And still, we have single point of failure. If the RAM or anything gets wrong, your whole server or your whole infrastructure goes down. Now, that is opposed to what we call horizontal scaling. Horizontal scaling is what we describe with the auto scaling, right? And what happens in horizontal scaling? Instead of replacing a single component, we rather add on another server, right? So we add another server. So horizontal scaling, we have one EC2. We bring on board another EC2 to come and help, like the throttle analogy, right? Then later on, we bring on board another EC2 to come and also help, right? We keep on adding EC2s. And with this one, we can add any number we want to add. Even 1 million, we can add 1 million EC2s. So horizontal scaling is possible to any number that you want to get to. But vertical scaling, you can't keep on changing the RAM to a certain level or point. You get to a point you can't go beyond that, right? With the vertical one, keep on changing the components and replacing it with what? A bigger one, a bigger one. You get to a point that you can't go beyond that, right? Awesome. If these two principles or these two things are clear, just say clear in the chat for me. Horizontal and vertical scaling. So with the cloud, we do horizontal scaling and not vertical scaling. When you have your service on your premise, you'll be doing vertical scaling, and that one there's a hard limit. Awesome, let's continue. Now our application load balancer, right? We've already seen this guy. Let's just walk through quickly. So the ALB distributes traffic, and I said it can do that also in a round robin or least connection. It just spreads it evenly, right? So it just sits there, application load balancer. Then the traffic that is coming, right? It says you go here, you go here. When one of them is even broken down, then it has now load balance between just two of them instead of what the three, right? Then later on, the auto scaling group will make sure that it fixes this one for us and replaces it with what? Another one. So this one needs replacement. Awesome. So health checks happen. Okay. It pings each server every 30 seconds, right? So this guy, the load balancer, is always checking whether each of these things are healthy. And then when it sees that you're unhealthy, it stops sending traffic to you. So over here, it will stop sending traffic to this one till it is replaced, right? Awesome. Then we have something we call SSL. SSL is, in a nutshell, or in simple words, is what enables us to get HTTPS. So when your website is HTTP, you will see not secured in the browser. But if it's on HTTPS, you will see it doesn't show that message, right? And we can have our SSL certificate on the ALB, okay? And then it will give our website what HTTPS. Let's not go too much into the technicalities of that, but this is just a secure way of transmitting internet information, right? Or at the application level. Okay, through a secure tunnel we call the SSL. Now, the last one, it enables us to do what we call path-based routing. This also, we will not go into the details of it, but most of the websites we use it, okay? We route requests to certain specific paths on the server, and ALB is able to handle that for us. Awesome. So this is the guy we saw, right? The conductor. Right now, we've opened him up a little to get to the details. Great. Let's move on. Now, the station master, auto-scaling group, right? This is where we set the rules. AWS adds or removes server 24/7. No human beings are needed. It is automatic, right? So I mentioned this thing called a launch template. This is where you define the kind of servers you want. So that each time it's adding a server, it will come and look at what you have in your launch template and create the server based on what your launch template specifies, right? I also told you that the scaling is not just like arbitrary or random. There's a maximum, there's a minimum, and there's a desired capacity, right? So your minimum can be around, let's say, 2. Your desired can be also the same as a 2, or it can be 3. And it's a maximum, it should not go beyond 6 to help save your traffic. So that it doesn't keep on scaling beyond a certain number, and at the end of the day, you go to your AWS bill and you start crying, right? Okay, the last one is the scaling policy, right? So if you have target tracking, right, there are about 3 of them, but let's just talk about target tracking. We also have the step scaling policy, but with target tracking, is they define it in a very simple terms. Please just make sure I don't go beyond 70% for 2 minutes. So if it's beyond 70%, then AWS will just add a server to it for you, right? Or do something just to bring it below 70%. So we can define the policy we want to go by, target tracking, or we can set custom rules, right? So if CPU is 20% for 5 minutes, remove 1. If it's more than 70% for 2 minutes, add a server. These are all policies you can define. So all of this falls into the AWS auto scaling groups, which we must also create and which we will create in our lab. Awesome. You got this one right? Are we good? Type good if you're good. You're good with the station master. Let's proceed. Great, great, great. We are almost done. We're almost done. Now, CloudWatch. Now, how do we know whether the CPU utilization is going beyond 70? There's a service on AWS, which is our eyes. It watches almost every service we deploy. It watches everyone. Then it picks what we call logs or information from these services. So on these services, like when you create an EC2 or server, you can monitor the metrics like CPU utilization, right? So you can collect these metrics from the CPU of the EC2 or the server you create. And when you come to CloudWatch, you can see the metrics being collected live, right? Then you can use these metrics to create an alarm or to trigger an alarm, right? So whenever it goes, let's say we can set it up so that when the CPU utilization goes above 70, we hit an alarm or we fire an alarm, and the alarm performs a certain action, right? So this is what happens internally with auto scaling. It's combining these two things, the CPU utilization or the metrics being obtained from the EC2 to fire a particular action. And the action that we are triggering is to do auto scaling. Awesome. And then, as I said, we collect logs from our application constantly, right? All of this with CloudWatch. So CloudWatch is monitoring all the services that we have deployed. And for our special case, we think about the EC2 or the servers that we are deploying. Great. Awesome. So EC2 reports CPU to CloudWatch. CloudWatch will fire that alarm when the CPU is more than 70%. Then Autoscaling group launches a new instance. So this can be like the typical flow, right, that we have in our setup. Awesome, very simple, right? Great. Now the last thing we will talk about, CI/CD. This is our six, lab six of week 3. And as I said, this is really, really optional. You don't have to do it. But if you really want to get a taste of what we call DevOps, this is a very good place to get that taste, right? To do that lab, to give you a taste of what DevOps engineers do. And one of the things they do, and it's on the job requirement of almost every DevOps role I've seen, is that you should understand the concept of CI/CD. What is CI/CD? In simple words, CI is continuous integration and continuous delivery, right? So we don't want there to be, we don't want any break whenever we are deploying applications to the cloud. So this is what happens. Developer is building the application on his laptop. When he finishes building the application on his laptop, he moves the application to a place we call GitHub. So I made all of you create a GitHub account, right? So we are building this application on my laptop, okay? And when I finish, I push all that I've done to GitHub. GitHub is on the internet, right? I put my changes to my GitHub. My GitHub is connected to wherever I am deploying or hosting my website. So let's say I'm hosting on AWS, right? So whenever I push a code to GitHub, using something we call GitHub Actions, okay, it picks up my code changes, runs certain processes through the GitHub Actions to now move the code, okay? Either some of the codes have to be built and packaged, right? So it initiates the building and packaging of the code, and then finally there'll be an action that continues to what? Move my new code to AWS for me, or wherever I'm serving my app. Then users will now see my app when they go to www.cloudwithchat.com. I may do a short demo for you to see right now, right? But the whole idea here is once a developer is building on his laptop, he is done and he pushes it to GitHub, okay, through the GitHub actions. So all of these steps you're seeing here, they're going to be handled by the GitHub actions. So it looks like it's just one step here, right? But this one step here is doing 1, 2, and even doing the 3, right? So it moves it to GitHub and through the GitHub actions, which run at the end of the day, everyone on their mobile phone or wherever they are, see the changes live and colored. See the changes live and colored. Are you ready to let me show you a demo of this right now? Are you ready? If I just type ready in the chat, and I'll do a simple demo for you to see with our own website, Cloud with Chat. A simple demo. So when the developers are working on the website, they are using CI/CD. If you make a change on the laptop, the change will be seen by you within some 2 minutes because everything is automated from the beginning to the end. You don't have to wait for 3 days before you see the change because everything's being handled by the GitHub actions that we've set up, right? Okay, people are ready to see some GitHub actions or CI/CD working. Good, I'll show you. So in the lab, you get to build something like that for yourself. But as I said, this is not really beginner friendly. I'm just telling you in advance. If all the labs were beginner friendly, this one is not. But not to scare you, you can still do it, right? And we'll provide you a solution to before the end of the week. Okay, looks like my guys are interested in seeing the ready. There are so many readies. I'm thinking of doing it tomorrow, but you guys are saying today. Okay, so I'm going to do it today. So let me just stop the slideshow. We are almost done with this. So let me go to our website. So on our website, right? So on our YouTube channel, let's go to our YouTube channel. So on our YouTube channel, we've uploaded one video. But the video is not seen, right? So let me get that video first, and then I go to our playlist. Okay. So over here, lab 3 student discussion, right? So this student discussion, I want the ID of this video, right? I'll show you something soon. So I'm feeling lazy today. So let's use ChatGPT to do that. So I paste it here, right? So I know what the ID is, but I'm just showing you something. So give me the video ID. So I'm going to pick the video ID here, and then I'll try to place it on the channel, right? Since we don't have it on our main page. Okay, because of internet, I think we're having a very slow loading. Why is it? It's not loading. Hold on, let me just fetch it. Okay, but even besides that, let me just pick one of these lab and show you something. So over here, where? Let me use lab number 4. Okay. So lab number 4, build a serverless image resizer, right? This is our lab number 4. We all see it, right? Build a serverless image resizer. Okay. So I'm going to put myself in the shoes of the developer right now. And I go to this folder over here. I go over here. I go over here. Then I try to go to week 4. Lab. No, let me go to week 3. Week 3. This still, that would be 2, right? Lab 4 is at week 2. Yeah, this one. Okay, good. Now this is the HTML file that builds the page, right? And I want to change this code here. So I open this with Visual Studio Code. Okay. Great. Then Visual Studio Code is what we use to open codes, to write codes, and to edit codes, right? So let's say I want to change something here. Okay, so the body starts from here. So week 2. Okay, good. So this is the heading, right? So in the body, we see this week 2, lab 4. Let me just be sure. Then bring up the web page again. Okay. So we see the week 2. This is what I was seeing there. Week 2, lab 4, serverless image resizer. So in terms of the code, it is here. Where is it? Week 2, lab 4. But this is not what I want to change. I want to change the heading. So the heading is somewhere around here. Build your own. So build on your own, right? 75 minutes. Then serverless image resizer. Yeah, this one. So I'll say I'll just add a real serverless image resizer. This is that I've added a real to it. Over here, it is not there. Let me show you. Over here, it is just, where is it? It is just built images, a real serverless image resizer. So I've added that into the code, right? Where is it? So this is going to be, okay, so build a, so I don't have to bring the a again. So just build a real. So I've just added this word. That's the only thing I've done, right? And I save my changes with, now after I save the changes as a developer, okay, what do I do? I open my GitHub, right? So I come here and I open my terminal. So this is how we move code into GitHub. You can use the terminal to do that. So I'll do git status. Don't worry, we'll have a whole session on GitHub probably tomorrow or next week. So just watch what, and it tells me I've modified what this particular file, right? And I say fine, I've modified it, and there's nothing wrong with it. So now I'll do git add. Git add means I want to now add the changes I've made here. So git status is in red. Whatever you see in red here means it's not being added to my website. So for me to add it to my website, then I have to do a git add, and I'll just give the name of the file I want to add, right? These ones, just forget about these ones. I just want to add this one. This one is called week 2, lab 4. Yeah. So I'm adding that one. The changes I've made, I'm adding the changes, and I hit enter. Now, when I do enter, it adds it on my local computer, right? Then I have to do something we call git commit. Git commit. Commit is just a way of me saying, hey, register this change with a message, right? And I'll write. So the commit message usually just tells me what I've done, the change I've made. So I'll just say added the word real to the heading of the lab, heading or title of the lab, yeah. So usually whenever a developer makes a change, you're not working alone or solo. Like right now, I'm working with other developers, right? So I must let them know each change I make. I must just let them know what I've done. That's why the commit message is important, right? So after I add my changes, this message will be seen by the whole team who are working on this software with me, right? So I do git commit and I add my message so that when any developer goes to my GitHub account and sees this message, he knows exactly what I did, right? So this is not the best commit message, but it's just a demo. So when I'm done, I hit enter. Then a message has been added. Now it is still on my laptop as a developer. I'm still on my laptop. So I have to now push this code to the GitHub online. When I push it to GitHub online, to the GitHub actions, right? So let me push it. It's just simple command, git push, that's all. So right now the code is going to move from my laptop to GitHub. So I enter git push, hit enter, and then it has moved it. It has moved the change to GitHub. Good. Now I'm done with my laptop. Now the GitHub actions is being triggered. Let me see if I can show you the actions, right? Live as it's being triggered. So the actions are being triggered. This is just for theoretical knowledge. You don't have to do this, right? Theoretical knowledge. So I come to, now look at here. Over here, the actions have been triggered. Now see what's happening here. Added the word real to the heading of the lab. So do you see my commit message has appeared here? And behind this, it showed me exactly what I've even changed here, right? It was just serverless, but now you see the word real has been added to it. So the actions is being triggered, right? These are the actions. If I click on actions, okay, that's already run. The action has finished running. So we didn't get to see the actions running live, but at least this is where you see the action has been embedded to the page. Hold on while it loads. Okay. So basically that's completed with the success, right? And we'll do this in the lab. You see how to create this access yourself. Now let's go back to the web page and let's reload. Now this is the old one, right? Let me just the word. So let me refresh. And voila, what do you guys see? Do you see the reel has been added here? So what I did on my laptop, when I just push it to GitHub, automatically GitHub picked it to the actions, ran all the actions, and then deployed it live to the website. So when any change is made, within seconds, it can be deployed live to the website. And this is what we call CI/CD. Continuous integration, continuous delivery. So continuously, I can integrate code, changes to the code, and the process will run automatically to get it to the end user, which is you and every other person, right? So you can open the same website and you all see that the word review has been added to our website. That's the lab for. I hope you liked the demo. Was it good? It was quite short, right? But at least you get to see what CI/CD is all about. So this is how we typically use Visual Studio Code with GitHub, push changes we make. The changes are seen by everybody. If there's an action, the action runs and then integrates it into the live web application for us. But it's a very simple CI/CD pipeline. It can be more sophisticated than this, right? It can be more sophisticated than this. Sweet, yeah, it has been sweet. Okay, so back to this. So continuous deployment. So every git push, so when I do the git push, automatically it runs, builds the app, catch if there are bugs, to catch the bugs, and if everything is safe, it now deliver it on our main website, right? If CI passes, automatically pushes the new version to AWS. Right now, I'm not using AWS for this website, right? I'm using a simple web hosting platform like GitHub Pages. So it just pushes the new changes there without doing anything. So the DevOps guy, this is what the DevOps guy does. He creates this whole CI/CD pipeline, right? So that when you, a developer, join the company and you push your code to GitHub, no one has to touch the code again. All we will see is that we will see the end result on our website. That's all. So the guy who does all of this automation for you, this guy we call the DevOps engineer, typically the DevOps engineer. He builds this pipeline so that when you push your code to GitHub, everything will be taken care of. The code will be checked for maybe vulnerabilities. If there are certain security vulnerabilities there, we can build it into the pipeline. So we can have security checks, code quality checks, all those stuff can be in the pipeline. Then when all those tests are passed, right? If we can have what we call unit tests. We run that every part of your code is correct and robust. All of it can be big CI/CD pipeline. So that once the developer pushes, nobody has to go and check whether there's a bug. Everything is automated till we get it live or maybe our staging website. Then if everything is good, then we can now promote it from staging to production. Yeah. So this is just a small glimpse of what those guys usually do with respect to CI/CD pipelines. This is extra knowledge. It's not meant for the cloud practitioner exam, but it's good to know. Okay, as I said, my purpose and the aim of this whole bootcamp, together with the team, is to give you guys a feel and a taste of all of these things happening on the cloud. And this is one of them, CI/CD. Good. So AWS also has DevOps services that does this, right? Code commit. So instead of GitHub, their version is called code commit. And they also have code build, right? When the code comes to the code commit, you can connect it to code build to build. Sometimes these Java applications, these C++, they need to be built, compiled and built. Then code deploy, right? It's also a way of pushing the code live to your server so it can be seen by all your users or clients. Then the code pipeline, it will orchestrate all of these things. Code commit, code build, and code deploy. So code pipeline is like what I am doing in GitHub Actions. GitHub Actions also automates all of this. But AWS has code pipeline, we can also do the same. And Cloud Mission, it builds infrastructure without clicking any buttons. So if you see this on the exam, just know that instead of going to S3 buckets, searching for S3, click on create bucket, all those that long process. We can just write a script. We can do that once we run the script. And build even all your VPC, everything from this one script. So the VPC you guys are struggling to build and put in the web server inside them, create MySQL. I can write a script, and that script will do everything from beginning to end. And we'll get you one demo for that, right? So that you see how to build all of the infrastructure with code. Okay. So CloudFormation is AWS way of building infrastructure with code. Just take note of that. Then also we have System Manager, right? This helps us to manage fleets of servers, hundreds and thousands of servers. Also, secrets and passwords can be managed with the System Manager. It's like a Swiss Army knife, right? Has almost everything inbuilt there. Okay. So with the rest, these are just a couple of things I just added here. 5 things that bite beginners. Funny, right? So stateful apps plus horizontal scaling. So if your app stores sessions, easy to data in memory, out breaks logins, right? Move sessions to Elastic Cache or DynamoDB. So what we are saying is that either when you're using just one server, people logging into that server, we assume that the server will store their login details and information, right? What about if more servers are being added? Those servers, do they have knowledge about of people who have logged in? That is the question. Because one server had if I logged in on one server, that server knew that I had logged in. But with auto scaling, we said that we will add more servers. Those new servers, do they know I have logged in? Yes or no? So to solve this problem, the answer is no, they don't know. So to solve this problem, we just have to store that data of me logging in somewhere else that all the new servers can access and know that I have logged in. It's as simple as that. That's all this one means over here. Also, next one, auto scaling without a load balancer, right? Auto scaling can launch 10 instances, but if there's no load balancer, only one IP traffic gets, like only one server will be getting the traffic still, because there's no conductor to tell people to go to the other throttles, right? So if there's no load balancer, you can create more servers, but see, still the old server will be under pressure because there's no load balancer. Forgetting to terminate the ALB after the lab. When you finish this week's lab, please remember to delete your ALB because it can cost money. Right now, most of you are on free tier. You won't feel this pain, right? But it's best practice to get used to destroying the services you create after you finish every lab. Maybe after 3 months, your free tier will be exhausted. I don't want anybody to call me and is crying about the AWS bill. So it just make it a habit. When you do any lab, when you are done with the lab, all the resources you created during the lab, delete them, right? Pipeline security in Git. Also, you see me pushing code to Git. You can push every code to Git. Make sure you don't push your passwords to Git because GitHub can get hacked by hackers. So even developers using GitHub, we don't push passwords in our code to GitHub, right? We make sure we avoid that. Okay, setting a minimum is equal to 0 in auto scaling. Always, your minimum should never go to 0. Why should it be set at 0? You need a server, right? So your minimum number of servers should just be 1. Awesome. That one was fast, right? So we are done. We are done. I'll just walk you through the lab that you have to do and we are done. Okay, one person has a question. One person has a question. Oliver, ask your question. Oliver, your hand is up. Okay, good. So what we've covered so far, why scaling matters, vertical versus horizontal scaling, application load balancer, auto scaling groups, cloud watch metrics, alarms and logs, CI/CD, right? At least you know what CI/CD means. Continuous integration, continuous deployment. And also, we look at AWS toolkit for doing CI/CD, right? Code build, code deploy, code pipeline, secret manager. We've seen all of that. So just review the slides. So the lab 5, you will be doing the auto scaling yourself. That's lab 5. And lab 6, which I say is not really beginner friendly, and it is really, really optional. But if you want to do it, you can go ahead. is when you get to build your first ever CI/CD pipeline yourself from GitHub to AWS. My team will provide a recording for this and this. But before we do that, as usual, we will let you struggle to do it yourself, right? Maybe somewhere Wednesday or Thursday, we will step in to all those who were not able to do it. We provide you a recording. Yeah, great. So let's go and check out the lab, and then I'll open the floor for questions, right? The lab. Then we are done. Our time is almost up. Let's do that quickly. So this week's lab, what you should do is lab 5. Lab 6 is strictly optional. I'm saying that again. So with lab 5, let's look at what is there. So this is a plan for lab 5. You're going to create your own load balancer. You create your auto scaling group with your launch templates. And then you test the setup to see whether the setup works, right? You artificially generate artificial high traffic. And then you watch whether your service will increase or not increase, right? Okay. So you create your launch template. The first thing you do, go to EC2 launch template, create your launch template with these specifications, right? A name, choose your AMI type, instance type, key pairs. You can use the existing one you've created already. Security group, you don't have to build a new one, right? Or you can create a new one called web security group. Allow port 80 from everywhere, okay, because it's a web server. Then the user data script, go to the advanced setting details, expand that one, and copy this user data script and use this, right? Then when you are done, click on create launch template. Then next thing is that you create your target group, right? Easy to target groups, create a target group. You fill in with these details. Then over here, in creating your target group, you give a target type, the name of the target group, the protocol, you choose HTTP 80. You can use the default VPC. Don't go and create any new VPC for this lab. Just use the default, it'll work. Okay. Then when you are done with that one, you click on create target group, right? Then after that, you create your application load balancer. Easy to, you go to load balancers, click on create load balancer. You fill in with these details, right? And then you click on create load balancer. It will do that for you. Last one, you create your auto scaling group. Same thing, easy to auto scaling group. Create it, fill in with these details. And then you click on create auto scaling group, right? Then it's where you actually trigger or test the setup. So you get inside your EC2, you do SSH into it. Then you run this short code. This short code just tries to create artificial traffic to your website, right? Or it just creates artificial CPU stress, right? Then the purpose is that if your CPU utilization goes high, CloudWatch will see it. It will trigger auto scaling group to multiply the number of CPU you're using. So if you realize that according to the policy you choose, it may become 4 or 6 or whatever number is the maximum, right? And then when you are done, you see that it has increased. And when the traffic is low, the number of EC2s will go back to the normal desired capacity. So you see that happening live. So when you're done with all of that, you just do your cleanup. You delete your auto scaling group, load balancer, target group, launch template, security groups you created, and then you delete your EC2 instances. And then you're done with the lab. So this is just a quick walkthrough of what you are expected to do for this week's lab. Awesome. We are done. Hope you enjoyed the session. 2 hours. You guys are great. Now I'll take 2 questions before I go off the call. So one from Irene. I'll allow you to unmute yourself. Then, okay, hold on.
Okay.
So
Good
Irene and then
morning.
Oliver.
Yes, sir. Good morning. So I was asking earlier
Who's going first?
with regards to
Oliver,
AWS.
Oliver, let the lady go first.
Okay,
Oliver, they
okay.
say ladies first.
All right.
Hold on. Okay, Irene, let's go. Irene, Lutrot.
Yes. Yes, sir. Good morning. I'm still having problems with the AWS. So I wanted to know if there's an alternative I have to use to get these labs done because I've been up since 2 a.m. this morning and they're telling me I have to opt for the paid version because I don't qualify for the free tier.
Oh, it does so. So it just means
Yes.
you have to create a new account. It means you have to create a new AWS account. Did you try creating a new one?
Yes, sir. I did. I did with two alternative email addresses I had. But then when it came to my card details, it still referred me back that I already have an account. And I cannot
Oh, so it's like AWS still sees
have
that
a
your
free
card
tier.
has been
I have
used.
to
Yeah,
go for
I
the
get
paid
you.
one. So I don't know which one to use now because I really want to.
To do the labs. Okay, so I what I think is happening
Yes,
is
and my number
AWS
I used
is
as well. I
seeing
use my
that,
Vodafone. Yeah, some stuff.
yeah, the same number. Wow. These labs,
A
okay,
different
sometimes
email.
if you are very fast with the labs, yeah,
Yes.
if you're very fast with the labs, you can do the lab within an hour and it won't cost you more than some cents or $1. That's if you are fast, right? Within an hour or two. So you can finish all of these labs in this course and you will still not pay more than, let me say, $5. So if you still really
Oh,
want to do it badly and you don't have any new card, then maybe you have to use that option. You will still pay something little. And make sure that you really clean up after you're done with the lab, else the bill will be huge, right?
okay. So,
So just
sir,
let me
what do
know
you
if anything
suggest
happens,
now?
just let me know. Just call me. Yeah.
Okay, okay.
So my
Thank you.
suggestion is you can still do all the labs, but yeah, my suggestion you can do all the labs, but just be careful. When you are done, clean up your resources. Yeah. So you don't get billed. Yeah.
Yeah. Okay, sir. Okay. Thank
Okay.
you.
Oliver, welcome. Oliver, please come in.
Noticing that my question has been answered in the chat, but I wanted to ask about the AWS billing. With regards to S3 buckets, are we billed for that as well?
Yeah, but S3 back is like almost insignificant bill if you're on
Okay,
the free tier.
okay,
Yeah, you don't have to
okay.
worry about that at all. Yeah.
Because I try as much as
Okay.
possible to close all my services, but I leave the S3 buckets running because I try to deploy. I'm actually working on an app and I'm deploying it on an S3 right now. So I was wondering if
Okay. Is it a
I'll
static
be.
app?
Yes, it's a static app. Yes.
Yeah, it's not really built. It's not really like it's built, but see the amount is in some few cents. Yeah.
Okay. Okay. But if the
Okay,
money,
Andrew,
if
your hand
I
is
don't
up.
have any money in the account anymore, I'll come to you, Oshad.
Ha ha ha, interesting.
Thank you very
Okay,
much, bro.
Andrews, welcome. Andrews, let's go.
Yeah, good morning.
Morning, Andrews.
Yes, so mine was also an experience that I had during the creation of the third lab. That is when we were about to create the RDS, the database. So, as Irene was also saying, like when I got there, the free trial was not available for me, but I think they asked me to upgrade my account. So once you upgrade the account, that is when you are going to have access to that depth or the text so that you can proceed. So I did that one before I got the access to do that one without being billed.
Okay. So my advice for the RD is that still you can do that lab. You see that lab for RDS, okay, the lab 3. I've created tools. If you don't want to upgrade your account and pay any money and you still want to use your free tier account, don't use RDS. Go to the option B. The option B, we use an EC2 instead of RDS. So, but I have recordings for both of them. So there'll be two lab 3. You see that there are two recordings. One for those who want to do RDS, which may not be possible for most of you doing the free tier, right? And then the other one is the one using an EC2 for your database. So there are two options, and I think I'll recommend you all do the option B. But if you still want to have a feel of RDS and you think you can still pay like $1 or whatever bill can come, please go ahead. Yeah. But make sure you turn the RDS off. Because if you don't turn it off, with the settings I gave you, at the end of the month, you'll be paying something like $20, which is like 200 cedis if you're in Ghana, or even more. The rate is now 12, right? So just be careful with some of the labs. And once you are done, if you don't want trouble, just clear the resources, delete all of them. All the things you create, always delete all of them. And you won't be billed beyond the 1 hour. So that'll be like a few cents. Okay. Oliver, is your hand still up? Or that was the old hand?
Old one. That was the old one. Sorry.
Okay. Okay, team, we are done for today. Sweet. Please deploy only one ALB. The ALB is just one, but the servers, for what we are doing, deploy just one ALB, right? Just one. We want to go with a very simple architecture. Okay, team, thank you so much for joining me for today's session. And hopefully, we'll have our last session next week. But after the last session next week, we'll give room, okay, for like 2 more weeks for you to finish your final project work. So one of my team members will reach out with a form. Those who want to do their final project work in a group, right? You just fill the form. And based on the information we collect, we'll give you a group to work with. And the groups will make sure that you're not more than, let's say, 6 or let's say you're not more than 7 in a group, right? And we may create the groups according to your time. In Namibia, we'll put people who are in Namibia in your group because you guys are like 2 hours ahead of us. So we don't want that conflict of. But if you want to mix up too, fine. Maybe we'll allow you guys to mix up and learn from each other. So maybe we will even have to vote on that, whether we should mix countries or we should let the countries work in their time zones. But if you want to become a remote worker, you must learn how to work with people from different time zones. I work with people who are like 4 hours ahead of me, 2 hours ahead of me, some even 6 hours ahead of me. Okay, that's fine. Awesome. If you enjoyed this, just give me a sweet before we check out. Any other announcement, we'll make sure we set on the page. So just look out for announcements also. And one last thing, there will also be a form. Those who finish all their first 4 labs, you can request for certificate. But if you want to wait to finish the 6, you can also request for that certificate. And the certificates will not be the same. Those who do 4 of our labs will get a different certificate from those who do 5 and also those who do 6. And those who do all the labs plus the capstone project, they get the super bootcamp participant certificate, right? One more thing, the challenge labs are optional. They are not part of what we are using to check for certificates. And also those who are not able to do any of the labs, right? We will create another certification pathway whereby you have to just answer multiple choice questions. When you pass all of it, we'll give you also a unique certificate. Isn't this interesting, right? We want to make sure that at least everybody gets a certificate before they finish. So if you think you couldn't do the labs because AWS never allowed you to create the account, don't worry. You watch all the videos, go through all the lessons, read all the slides, and we will give you an objective test, MCQ type, 65 questions. When you pass, we give you a certificate, right? And we'll state it on it, what you did. You cover the course material, you finish our quizzes. But those who do the labs too, will give you a different certificate whereby we state on it that you covered our course materials, you finished all the labs, or you will state the names of the labs you did, and then we'll give you the certificate. Okay, sounds good. Good. Thank you, team. Fifi, last question, and I'm off. My time is up. Last question.
All right.
Yeah.
All right, so thank you. The first question is, with the submission of the labs, are you going to give us a form where we will attach the various screenshots to, so that we submit the labs that we have completed? And then
Yeah,
the second is, in the attendance sheet, there is a feedback. What is your expectation for the feedback? Because after, I'm confused. What to
any
enter?
feedback you have for us? Any feedback you have for us? It's just like a feedback.
Okay. Okay.
Any feedback at all, yeah. Something we need to improve, something we need to work on. I'm more interested in the negative feedbacks even than the positive feedbacks. So if you're doing something wrong, let us know. It is an open source community project, right? Let us know how we can make it better next time. So when we are done with all of this bootcamp, I will start a new video session, right? That one is just for exam prep, no labs, just exam prep kind of thing. So that one is also coming up soon after the bootcamp. Okay, team, take care. Have a wonderful day. Bye bye. Happy learning.